In this video, I'm going to be talking about the rock cycle and specifically dissecting this diagram that we've been referring to in a couple of our activities in the class. Understanding the rock cycle is really key to thinking about energy transfers in the Earth system. So I wanted to make sure that everybody is on the same page with what this diagram is illustrating and the processes that it's trying to discuss. So the idea behind the rock cycle is that material in the Earth system is constantly being recycled. We have sort of the bulk materials that make up the planet, and the way that they change and sort of move through the rock cycle determines what kinds of rocks are forming and how they're being broken down and how those constituents are being moved around in the Earth system. So with the rock cycle, you can really start at any point and then move from that point into other parts of the Earth system. So let's first just sort of talk about how this diagram is set up. You can see that we have a circle here, and then there's this sort of thick black line drawn here, and that is supposed to represent the surface of Earth. So anything that you see above that line is happening at or above the surface of the planet, so things that we would be able to observe as organisms that live on the surface of Earth. And then everything happening below that line is happening deeper inside of the planet. Most of these processes that are illustrated here are things that are happening in the crust of the Earth, so the very outer layer of the planet, but some of them are things that might happen a little bit deeper, like maybe in the mantle or the sort of, especially in the upper part of the mantle. And so these sections are labeled, as you can see here, above ground processes and below ground processes. Okay, so the next thing to know about this diagram is that each rounded box that you see is a type of rock or an object. So there's the four types of rocks that you've been learning about in this chapter: extrusive igneous rocks, intrusive igneous rocks, sediment, sedimentary rocks, and metamorphic rocks. We also have magma, which is melted rock material when it's underground. When it's above ground, we call it lava. When it's below ground, we call it magma. So we have these different components of the physical objects that make up the rock cycle, and they're connected by geologic processes. So if we want to start here with extrusive igneous rock, like basalt. This is a rock that's really common in Washington State because it is rock that is erupted onto the surface of Earth and crystallizes on Earth's surface. So it's a very rapidly crystallizing igneous rock. What can happen to that rock? Well, when it's on the surface of Earth, it can get broken down through weathering processes. So we can take a piece of basalt and break it down through physical and chemical weathering. Those pieces, of the smaller pieces of basalt, can get moved through different transport processes. So it can be moved in a river, it can be blown by the wind, it can travel in a rock fall, because of gravity. And when it stops moving, we call that deposition. So these three processes right here are kind of like the erosive processes that break rocks down and move them around on the surface. A broken down rock, so if we take basalt and break it apart into smaller fragments, we call that sediment. So sediment can be moved around through these transport processes. There's a couple of different directions that sediment can move in. So into the soil cycle, we don't talk about that a lot in this class, but what that refers to is the chemical decomposition of sediment into other types of minerals. So if we break down a granite into all of its individual minerals, some of those minerals will decay into clays and get mixed with organic material and become soil. But again, we don't talk about that too much in this class. What we do talk about a lot is when sediment gets buried underground. So through various depositional processes, sediment forms layers on the surface of Earth, and those layers can get buried deeper and deeper into the planet. And we call that burial. Compaction is exactly what it sounds like. When you get enough material piled on top of that layer of sediment, it gets physically compacted. And then eventually, when it's deep enough underground and when the chemical conditions are correct, individual loose grains of sediment will get cemented together. And that process is, if we think about it on a more microscopic level, it's the individual grains getting glued together by cement that grows in between each of the grains. So when that process happens, when we get individual sediment grains cemented together, it goes from being loose sediment to sedimentary rock. So sedimentary rock is a rock comprised of individual grains of minerals and other small fragments of rock. The path is complicated. It's not a circle. So sedimentary rock, a few different things can happen to it. It could get buried even deeper. So when it goes from the sort of crust of the earth down into the lower crust, the conditions within the planet are very hot and pressure is very high, and that can trigger physical changes in the sedimentary rock. And it can, if it gets heated up and put under enough pressure, it can get metamorphosed into a metamorphic rock. If it continues to be buried deeper than that sort of stage when it goes from a sedimentary rock into a metamorphic rock, it actually gets so hot and the pressure gets so high that the material can fully melt back into magma. So that's what we see here. And then as that magma travels up towards the surface of Earth, the temperature goes down and the pressure goes down, and that can lead to eventually to the crystallization into an igneous intrusive rock, which is a rock that forms directly from magma but crystallizes underground, or an igneous extrusive rock, which crystallizes above ground. So I kind of sort of followed this outer circle on this diagram, but ignored these internal arrows here. And those are really important because, again, this is called the rock cycle, but there's not a single path that material takes on it. It can jump from one spot to another. For example, a sedimentary rock doesn't have to travel sort of all the way around this circle to eventually become an extrusive rock. It can, sediment can get buried and cemented together into a sedimentary rock, and then through uplift, a tectonic process, that material can be brought back up to the surface and exposed on the surface of Earth. So that would be why we have rocks like the Chuckanut Formation, which our campus at Western is built on top of. It's a big, thick sedimentary unit. It's a sandstone, and if you look closely at the rocks on campus, when we get to go back to campus, you'll see that it looks like it's a bunch of sand that's been compressed together. Metamorphic rock doesn't have to go to melt into magma. It too could get uplifted and exposed on the surface of Earth. And both extrusive rocks and intrusive rocks could be buried and with enough heat and pressure turned into metamorphic rocks. So metamorphic rocks can form from any other type of rock, a sedimentary rock, an igneous intrusive, and igneous extrusive. They can all eventually be changed into a metamorphic rock. So the path is complicated, and in order to figure out exactly what happened to a rock, you have to look very closely at the material that the rock is made out of, the minerals, and the shape of the grains, and all of these different components. And I think that that's it for this explainer, and so I'll just end it there.